Big data security and privacy. Abstract. Earlier, if we talk about 15 to 20 years back, data, traditional data, was limited because social media, online transactions, e-commerce, etc. was not in that much use, and it was easy to store, process and protect the data due to its small volume and structured format. But day by day technology evolved following the world, and new services get introduced due to which data generation increases, which leads to the development of many techniques that can be used to store and process this amount of data. These technologies, with their ability to extract information from large data sets for better decision-making process, have created ways to maintain data, process data, and new growth opportunities. But if data is not well protected from threats like phishing, hacking, etc., all these processing becomes futile, as if data falls in wrong hands, it could be misused. There are many ways to maintain data security and privacy, but still it could be violated if not carried out properly. So while dealing with data, security and privacy becomes prime concern in order to protect it from attacks. Our purpose in this paper is to discuss the challenges faced while maintaining big data security and privacy, and to explore some techniques that are used to deal with these challenges. 1. Introduction. We all are living in the era where data is generating rapidly. Even the data generated in last 3 to 4 years is more than the data generated earlier in the whole century, and it's clear that future is filled with more data, so that means we are going to deal with a huge amount of data which keep on increasing. This data is generating from various platforms like social media, e-commerce websites, stock market, data of particular organizations, and list goes on. This data holds valuable information like how users share, view, or engage with content in case of social media, ratings and reviews of customers, preferences, shopping behavior, payment information, etc. in case of e-commerce, market data and trade-related data in case of stock market, and so on. And our concern is to extract information from this much data for better decision-making. Big data is a technology that is used to analyze and extract the information from large and complex data sets such that traditional data processing application software are incompetent to deal with them. Big data can be applied in various fields like e-commerce, banking, chemistry, data mining, cloud computing, finance, marketing, stocks, healthcare, agriculture, etc. It is a fast-growing field with exciting opportunities. That means with big data, there comes big opportunities but also big threats and challenges because of the volume and variety of data we are dealing with, and security and privacy of data is one of them. This security and privacy issue cannot be ignored, and it is necessary to protect the sensitive personal information of customers from online criminals, because data is an important asset to any organization and also for the millions of customers who trust such organization with their information. 2. Challenges in data privacy and security. Big data is an emerging technology enabling organizations to have a greater insight into their huge amount of data for making reliable decisions for their business. The accumulation of data in big data systems also makes them a target for hackers. Organizations should be able to handle this data efficiently and must protect sensitive data so as to comply with the set of privacy laws. Securing and maintaining privacy of big data is difficult because of multiple reasons. Some are mentioned below. 1. Complexity. Earlier, when big data didn't come into existence, we used to store and process data in databases like Oracle, and it was specific that how we need to deploy our database, like for 6 to 7 different servers, and it was easy to protect them. But with big data we deploy, for example, Hadoop system on thousands and thousands of servers, and because of this our infrastructure becomes much larger and it becomes difficult to protect. 2. With big data we get the value of our big data investments only by letting many analytics to have access of that data, and if an outsider, who could be some evil business rival or hacker, got the access, then he/she would have many sensitive information. And the problem is that for an outsider, and because big data technologies do not provide an additional security layer to secure the data, gaining such access may not be difficult. Security of data often relies on perimeter security systems. And if 3. Velocity and volume. Data feeds of multiple types combined together come from different sources in real time with different security requirements. Like when dealing with high-tech environments or retail or banking, or simply while dealing with real world where decisions need to be made very quickly on data, we are having real-time security solution for alerting, monitoring and blocking, and sometimes these alerts leads to many false positives, but in order to make decision quickly, we often ignore them, which results to develop some loopholes. 4. Environment. If we look at big data environment, it is not as simple as traditional database. It is difficult to manage as data warehouses store massive amounts of sensitive data such as personal data, financial transactions, etc., and it is required for organizations and businesses to have a proper privacy and security infrastructure that enables only relevant data to be viewed by their employees. And it is not always an outsider. Sometimes an organization may have corrupt IT specialists who can sell important information for their benefit, as this perimeter-based security are generally used for securing entry and exit points, and what this IT specialist do inside the system remains a mystery, and he/she can mine unprotected data. 3 methods used to deal with data privacy and security. There are many ways to deal with these challenges that come up with big data privacy and security. Companies often use different techniques like de-identification, encryption, etc. to deal with them so that no one could extract sensitive information from the data sets. One, de-identification is a traditional technique which is used to prevent someone's personal identity from being revealed. This process is adopted as one of the main approach towards data privacy protection, and it is commonly used in many fields of multimedia, communication, biometrics, big data, etc. To understand this technique, consider that we are having a medical data consist of certain attributes like patient's name, Aadhaar no, date of birth, gender, PIN code, visit date, diagnosis, medication, total charge. So before releasing this data to third party, we will de-identify the data by removing patient's name and Aadhaar no, and in this way sensitive information will be hidden from the third party. But it is not guaranteed that data is well protected here, as if third party is having another election data set of the people living in that area having attributes like name, Aadhaar no, date of birth, gender, PIN code, party affiliation, and date voted. Even after removing patient's name and Aadhaar no from medical data, there are few attributes that are common in both datasets, and i.e. date of birth, gender, and PIN code, and this third party use this common attributes, which are said to be quasi-identifiers, as a source to connect both dataset and extract sensitive information like patient's name and disease diagnosed, and this type of attack is known as re-identification attack, and an actual survey similar to this scenario was conducted in US, which has uniquely identified the data of 87% population using this quasi-identifiers. Quasi-identifier is the minimal set of attributes which is used to uniquely identify the data. That means only those attributes will be taken as quasi-identifier which will be enough to extract hidden information from another data set. And this re-identification and linking attacks take place mainly because of quasi-identifier. So in order to prevent our data from such attacks, we should mask the values of quasi-identifier using suppression and generalization-based anonymization methods. In suppression, data do not get revealed, it is hidden. We suppress quasi-identifier using special symbol like asterisk. For example, we are having a data in which a person's age is 36, so to suppress age we can write age equals 3, which means that age lies in the range. The quasi-identifiers are replaced with more general but consistent values in generalization. For example, age 36 can be replaced by age 40. But due to this reverse process of data re-identification, which can be used to identify individuals' data such that the sensitive information may be linked back to an individual using de-identified or anonymized data. The notions of K-anonymity, L-diversity, and T-closeness were proposed to prevent data from being re-identified. K-anonymity. Concept of K-anonymity was introduced to address the risk of re-identification of anonymized data. LaTanya Sweeney introduced the K-anonymity privacy model in her paper Protecting Privacy When Revealing Information, K-anonymity and its Implementation by Generalization and Suppression in 1998. A dataset can have the k-anonymity property 1, 2 if we coarsen quasi-identifier attributes such that every tuple in the table shares its quasi-identifier value with at least k1 other values present in the table, or simply we can say that in each release of data and at least k1 individuals cannot perceive the information for each person in it. To understand k-anonymization problems, let us consider a table of a medical data having 10 rows and 7 columns, where each row represents a record relating to a certain individual, and the entries in the various rows do not need to be unique. The values in the columns are the values of the table's members' characteristics. Let us first have the complete table of a medical consist of name, Aadhaar no, PIN code, age, nationality, and disease, and after removing key identifiers that are name and Aadhaar no, we have another table which consists of remaining non-sensitive and sensitive attributes.